Good morning, all. I'm Dr. Gayathri NS, Assistant Professor of Chemistry, working in SNS College of Engineering. In previous video, we have seen the synthesis of nanomaterials. There are two approaches, top-down and bottom-up. And also we have seen the difference of top-down and bottom-up approach. Now, we directly move on to the best method of synthesis of nanomaterials, that is sol gel technology. See the gel material prepared from the sol. It is in the nanoscale meter. Material processing by sol gel method. Sol gel process is very long known method. This technique was rediscovered in the early 1970s when glasses are produced without high temperature and melting point. Sol gel is a chemical solution method. It is also called as chemical solution method for synthesizing nanomaterials. It is also used to make ceramic, glass materials in the form of thin film, fiber, powders, etc. The sol is a colloidal and a molecular suspension of solid particles of ion in a solvent. A gel is a semi-rigid mass that forms when the solvent from the sol begins to evaporate and the particles or ions left behind begin to join together in a continuous network. That is called as sol or gel. So it is called as sol gel method. And sol gel method is a wet chemical method that uses either a chemical solution or colloidal particles to produce an integrated network, that is gel. The metal alkoxides and metal chlorides are the typical precursors. They undergo hydrolysis, polycondensation reactions to form colloidal, that is a gel, a system composed of nanoparticles dispersed in a solvent. The sol evolves then towards the formation of an inorganic continuous network containing liquid phase, that is gel. The formation of metal oxide involves connecting the metal centers with oxo or hydroxo and also metal oxo or metal hydroxo polymers in solution. After a drying process, the liquid phase is removed from the gel. Then the thermal treatment may be performed in order to favor further polycondensation and also it enhances the mechanical properties. And the example for the sol gel method, a silicon in hydrolysis and in the condensation. First we are going to mix the reactive materials, and first hydrolysis and then condensation we get a sol and gelification and the gel formation occurs. Sol formation, the hydrolysis of metal organic reactant in an organic solvent. This is miscible with water or inorganic salts in water, result in the formation of sol, that is hydrolysis method. Gel formation, the condensation followed by polycondensation of sol, result in the formation of gel. Water condensation, hydrolysis, species condense releasing water. Alcohol condensation, it releases alcohol. After aging in the sense of the cell, it remains for a long time, so the polycondensation occurs. It exits 7 days, is critical to prevent of cracks in gels. That's why. Next process is drying. It is nothing but a removal of pore liquid, the extra liquid in the colloid. And it is an example for the sol gel method. Material processing by sol gel method. First we prepared sol and then to gel, and it is dried and it is grind and we get the final product. We are sieving, these are the sievers. The fifth picture is the siever. In that a particular size of the material we can get. A particular size can be filtered and we get. And this is the same images of the salt gel method. We get salt or gel from the salt gel method, and it is analyzed at a salt gel flow chart. First we mix the reactors and hydrolysis and condensation. We get salt gelification, that is the polycondensation occurs and it is aging, gel formed, and drying, we get aerogel.